So since we went through these two systems, it started to bring me around to thinking differently about this. And as I said before, what I started to think was is to get the pressure off the shell. And that was part of it, but the conclusion that I eventually came to was that when a drum is vibrating, it is a vibrating mass, and any type of pressure against it whatsoever is going to either take out frequencies or it's just going to plain choke the drum. So what I had done over a period of years, and I started working on this one, I had 1973 is probably when I first started to fool around with this. So I didn't develop the RIMS concept and come up with that idea probably until about 1978 or 79. And then when that worked, before I really kept going with it, I probably had it on my drums for a good 6 to 10 months before I did anything else with it. And finally built one for each drum, and each time it sounded better, I started thinking, well, this is going to work because it's not creating any problems with the drum. It's not damaging the drum in any way. So let me show you what the conclusions that I came to from the other two failures, or attempts I should say, was the fact that I needed to find a way to divide this center of gravity in half. Since the center of gravity goes down through the drum, if the drum is sitting here, it's right in the center of the drum. As you start to tilt the drum, now the center of gravity is right up here because I'm holding the drum like this. But if you want the drum in a plane position, what you've got to do is take this weight, and this is a 10-inch, so this is probably somewhere around 7 pounds. You've got to divide it in half. What the RIMS system does, it divides the weight of the drum in half. So if this drum is, say, 6 pounds or whatever, then this is holding 3 pounds, this is holding 3 pounds. Now, you're still going to have 38 or 40 pounds here, but you notice it's not on the drum. It's now being applied to the side plate, which is taking all of the stresses. And one of the other things I wanted to mention was when you talk about developing something, inventing is really very easy. The problem is understanding the problem. The more you understand the problem, the more you can devise something or invent something that solves those problems. So what I came to, the conclusion was, when you get the stresses off the shell, put them someplace else that has nothing to do with the drum. The RIMS system has nothing to do with the drum. It's just a holder, but it does something very complex. It's a simple invention that does something very complex in holding the drum, dividing the drum's weight in half so there's no stresses on any part. Now, when this is holding the drum with these 3 or 4 pounds here and 3 or 4 pounds there, the drum is just setting in it. It's not pushing against the shell. All the weight is going perpendicular, is going down, which allows the shell to vibrate, allows the shell to move in and out. When you start putting pressure on a shell from the side and that type of weight, you're now restricting that shell from vibrating. So the whole idea of the RIMS system was to divide the weight of the drum in half and to hold it from a natural point that you don't have any of the stresses transferred to the shell, but all transferred to the side plate. So that's basically the RIMS concept, and that's what I ended up with after about 6 or 7 years of working on it. So now we have the RIMS band, which the concept I came out with, and this is the aluminum system, the new alloy system we came out with in 2000. But I want to just say briefly, show you something that I discovered with the old RIMS. And as I said before, inventing is easy. It's understanding the problem that's difficult. And when I first came out with it, I ended up going down to the hardware store and finding some material. They were out of steel, so I ended up getting a piece of aluminum and rolling it in a half circle like this. Put it on the drum. It was a 13-inch, about 9 by 13. The drum sounded phenomenal, no matter what position you put it in, and that was pretty much, I thought, problem solved. No stress on the drum. This is working great. However, when I went to manufacture them, I didn't think about the material. And I went to a shop nearby that eventually made a lot of rims for us. And I showed him the aluminum one, the basic one I had, and he said, well, you know, aluminum is expensive. And he said, you'd be better off going with like cold rolled steel. Besides, he said, what are the finishes on drums? I said, well, chrome. He said, oh, polish is great, chrome plate's great, so we went with steel. I never even gave it any thought. However, over the years, drummers would call me and they would say, boy, I got one on a 10-inch drum and they sound great on my 13-inch and my 14-inch, but on my 10-inch, the drum just absolutely chokes out totally. It's unplayable. And I thought, well, maybe it's just a bad drum, probably bad bearing edges or something. But after, I think it was around 95, I had a gentleman call me, a professional player in New York that I knew, and he had just gotten a brand new set of drums. I think it was a Noble and Cooley set. And he said, I put your rims on the 3 toms, and he said, same thing, the drums choke so badly I can't use them. And I said, well, what do they sound like when you take them off? He said, they sound phenomenal. They're very resonant, they're great sounding drums. Put the rims on them, they go dead. I said, could you send them to me? He said, okay, shipped them out to me. Sure enough, I took the drums out of the box, struck them, took the bands off, took the rims bands off, sounded great. So we had used a professor over at the University of Minnesota to do some consulting on some patent work that we had done when I was doing work with percussion. And I took the drum over and I said, why is this occurring? Hit the drum. And he said, well, take this thing off. I took it off, held it up, struck it. He said, okay. He said, you've got a piece of cold rolled steel there and it's chrome plated. I said, okay. He said, when you chrome plate steel, it gives it a pitch. It hardens the material. And that pitch is probably conflicting with the pitch of the drum. He said, now this is probably great if you're going to hold a planter. But he said, you're asking this thing to hold something that's vibrating, and that's what it's supposed to allow it to do, is to vibrate. And he said, even though you've got these little rubber things in here, there's still enough vibration that's going into the steel and going back into the drum, and you're basically getting a type of phase cancellation. So that was sort of when I realized, well, that first one I built worked so well, I never even thought that the material had that much to do with it. But like I said before, I didn't take the problem far enough to understand it. When I finally learned this, it was more understanding of the problem. So what I ended up doing, I went over to a place in Minneapolis, a place called Reynolds Brass and Aluminum, and I said, what would be the best aluminum to go with that would not transfer vibration? Oh, he says, this is the one you want to go with. And he said, you can anodize it, you can polish it. But he said, when I told him the problem, he said, but don't chrome plate it, you're going to be right back where you were before. The only problem was, steel at that time was maybe 13, 14 cents a pound. Aluminum was probably around $1.70 a pound. I think it's probably somewhere around $2.30 a pound now. But the thing is, when I made the ones up for the drums for this Noble and Cooley set, put them on those drums, the drums just sounded phenomenal. They just totally opened up no matter what angle I put them at. Also, the gentleman we consulted with, he said, you know, touch as few places as possible on the drum. Now, the one thing I found is when you attach these, you want to go at 180 degrees because that's the easiest one to get. It divides the weight of the drum easiest just between these 2 points. And then just have one in here. That basically keeps the drum from rocking. So the only thing you're doing is you're dividing the weight here. And if the drum weighs 8 pounds, this is basically taking 4 pounds, and this is taking 4 pounds. So you don't have the stresses on there like you had on the side plate. The side plate takes all the stress, so that's the way you want it. But that's why we came up with this system, and I think it's an excellent example of talking about inventing and how you need to understand the problem. Inventing is easy. Once you know how to solve it and you realize what you have to work with and what you have to do, that's sort of the easy part of it. So anyway, I thought you might find that interesting.